Hi all. In this video I'll show you how would you be able to prove that the Earth is a sphere and rotating even if the sky was covered in clouds 24/7. So how would you prove this? Well, you'd prove it with a pendulum. So say we had a pendulum with a wire that is 67 meters in length and the bob or the weight at the bottom is 28 kilograms. Now here's a model of the Earth. We have the equator here. It is spinning on its axis at an angular velocity omega, right? And that is in the counterclockwise direction. Now, to do this experiment, we'd have to go up in different latitudes. So we'll start at the South Pole here. So we set up our pendulum like so. And the plane perpendicular to the pendulum that is stuck to the Earth is coming out of the page. So we'd set this pendulum in an oscillation. What we'd notice is that it'd precess or turn around in around 24 hours. So roughly 24 hours. And that would be in the counterclockwise direction. Now, we'd move up further in a further latitude to say negative 40 degrees somewhere on the Earth, and we'd run this experiment again. We'd find that it'd precess in a counterclockwise direction, but it'd be a lot slower precession. And finally we'd set up this, well not finally, but we'd set up the experiment again on what we'd call the equator, and we'd observe that there'd be no precession at all. Going up further north, we'd do this experiment again, say at 40 degrees or whatever degrees latitude, and we'd find again that it'd precess, but in the opposite direction. So it'd precess in the clockwise direction. And finally we'd do it at the North Pole, and we'd find that it'd precess at the 24 hours again, but in the clockwise direction. So this opposite precession proves that the Earth is a sphere. But why is this the case? Well, I'll give you a formula, but I won't derive it here because it would make the video much too long. But for an observer on Earth, they would observe acceleration equal to the gravitational field acceleration of the Earth minus 2 times omega cross product with the velocity of the particle, or in this case the bob, minus omega cross product with omega cross product with r, which is the Earth's radius. So this is the term that we're interested in. It's called the Coriolis Term. And this is what causes the bob to deviate along with the centrifugal term here. So this is called the centrifugal term, or the centrifugal effect. And of course this is the gravitational acceleration of the Earth's field, gravitational field. Now, so say if the Earth was a disk, if the Earth was just a disk and we were an observer on this disk, and we'd set this pendulum up, and this disk was turning counterclockwise, so this direction. Now, we would only observe, no matter how far and up and down this disk we would go, that it'd just deviate to the right. Moreover, if this disk wasn't even spinning, so draw this disk again. If this disk wasn't even spinning, we would observe that it would just oscillate back and forth, and it wouldn't even deviate from its straight path. Now, by how much does the spinning Earth precess this pendulum? Well, the angular velocity is given by omega, negative omega, sine by the latitude. So the latitude of the Earth, so at your position on Earth, and the time of the precession, how long it takes to go around in the full circle, is given by this. 24 hours divided by the sine of the latitude. Now, this experiment was in fact done by Leon Foucault in 1851, and he did it at the Pantheon in Paris. So I think Paris has a latitude around 49 degrees. So 49 degrees. So the time for the precession would have been around 24 hours divided by the sine of 49 degrees. This works out to be 32 hours. Now, this works out to be a precession of around 11 degrees and 15 minutes per hour. And this was observed by Foucault and his everyone there that attended that experiment. So you see that the Foucault pendulum, it proves that the Earth is rotating on its axis, and it can also prove that the Earth is a sphere by performing the experiment at different latitudes. And of course, museums all across the world have a Foucault pendulum to show this. And there's even been an experiment performed at the South Pole and showed that it precessed at a counterclockwise direction. So I'll just show that in the plane. So on the Earth's reference plane, and here is the amplitude of the pendulum. Now, in the southern hemisphere, we'd set the pendulum in motion. We'd set it from south to north. So we'd set it in motion, and it would deviate to the left, like so. And it would keep deviating to the left like so. Right? Now, we do the same experiment in the northern hemisphere. Whoops. With that being north, that being south. Again, we'd just get a compass, say, and let the pendulum go pointing just near the north, and it would deviate to the right. And keep deviating to the right. And it'd precess like this. So, northern hemisphere, and the southern hemisphere. And that's what you would observe. So in the southern hemisphere, the precession would be counterclockwise in the Earth reference frame. And in the northern hemisphere, the precession would be clockwise. Again, in the Earth's reference frame, of course. So, that's how you'd prove that the Earth is rotating and is a sphere, by performing this experiment at different latitudes. Thanks for watching. I hope you've learned something. Please like the vid and subscribe to my channel. Thanks.